Okay, we're going to look at unit 5b.4, completing the square to find solutions. Now this is going to be pretty new to most of you. I don't think many of you have done this before. This is yet another way. Remember what the goal here is. Again, the goal is to find solutions, roots, zeros, which all stand for where does the parabola cross the x-axis. So this is the big picture. Keep this in mind. We're thinking about the parabola and where it's crossing the x-axis. Before we do completing the square, I want to show you why we're doing this. This always seems to be the question of why we're doing this, okay? So I want to show you something. This is not completing the square. This is the introduction. So you can see where completing the square comes from and what we're doing and where the numbers are going. All right, so the first thing, we're going to talk about a perfect square polynomial. Okay, perfect square polynomial. This is a perfect square polynomial, and I'll show you why. This is a special polynomial that we've done before, so let's factor it, and I'm going to show you what we're doing here and why we're doing it. Okay, so if we were to factor this, let's start with it has to equal to 0, which it is, so we're good. Next, GCF. In this case, the GCF is 1, so we don't have to do anything. ABC. A is 1, it's invisible, B is -4, and C is +4. Step 4 is to do our magic X. 4, -4. So this is -2, -2. Remember that creates a magic X on them, and X magically appears. And if you were to do your method, whatever your method is, once you're finished, you will get this, X minus 2 times X minus 2. The two factors are exactly alike, so we can really write it like this, because it's repeated multiplication. That's what makes this a perfect square polynomial. That is going to be our key to completing the square. We are going to force every polynomial into a perfect square. We're going to use algebra to make it into a perfect square. So our goal for this, and why we're doing this, and this is sometimes some people, it depends on your thinking. Some people are like, I don't care, I'll just follow the steps. But you're going to force the polynomial to be a perfect square. By using algebra. Again, all the rules of algebra still apply here, so we have to be careful. We're going to use all the rules of algebra. And we're going to create perfect squares so it's easier to solve. Okay, so that's what's going on here. That's what completing the square is all about. We have to make the polynomial into a perfect square, that we're completing the perfect square. Okay, so we shorten it up as mathematicians and say we're going to complete the square. No numbers disappear. Nothing happens. We are just using algebra. Nothing goes away. We are just using algebra to make it so it's easier for us to solve. Okay? Let's see how I want to do this. Let's do an example, and at the same time I'll write the steps next to it, because this is really brand new for you guys. And so I think if I just give you the steps, it's going to be a little confusing. So let me give you one that'll work, and I'm going to do it over here, and I'm going to do the steps over. I'm going to write the steps out over here. I think that'll be the best way. Now at this level, when you get to Algebra 2, it doesn't matter. But at this level, you only want to complete the square if your lead term is a 1. So in this case, our lead term is a 1. If our middle term is even, and it doesn't matter what this is. Okay? So here's our problem. So that's just our problem. Okay? So this problem is not a perfect square. If we were to factor this, I don't even know if it's factorable. It is not a perfect square, so this is not okay. So we have to make it into a perfect square. Okay? So the very first step to make this into a perfect square is we have to change the c value. And in order to do that, we need to move the current c value over to the other side to get it out of the way. So we're going to minus 17 from both sides, because 17 is not going to work. That's not a perfect square. That doesn't work. So we need to get rid of that value. We're going to change it. Okay? So I put a negative 17 over here. So what I say for this is we're going to move the c to the opposite side. Getting it out of the way, basically. We got to get the c out of the way because we need a new c. So I'm going to put right here, giving room for the new c. Because that c doesn't work to make a perfect square, so we need a new one. Okay? The next step is we're going to put a box on each side, a square. Now, this is not absolutely necessary, the box, but we do this so we don't forget. We got to fill in the blank on both sides. So that is going to be part of what we do. We're going to add a box to each side because that's where we're going to put our new c. Okay? Then we're going to work on 2 steps at a time. So underneath, we're going to create a space for our perfect square. Create a chunk with parentheses, I don't know how to say that, for our perfect square. And here's what I mean by that. I'm going to put parentheses here and a square because that's what we're heading for. So we're going to work on these 2 steps at the same time. The x is always just going to come down. So the x, put an x in the parentheses. So I'm kind of writing out, as I'm doing this, I'm writing out every single step I'm doing. You may not need all these steps as we go. So this becomes just x. It didn't go away. Remember, we have a square here, so it's still an x squared. We just are moving it, and we're going to factor it into a perfect square. Okay? The next step is to divide b by 2. By 2. In other words, b over 2, or b divided by 2. And we're going to write that in the parentheses. I'm running out of room here. Okay, so half of 8, just the 8, not the x, half of 8 is 4. So that goes in the parentheses. Okay, now what goes in the box is the square. And I know to do this because, look, it's telling me I need to square that 4. So you're going to square the results of step 6 and put it in both boxes. That's why we're creating that new we're creating that new c that's a perfect square. You can't just put it in one box because we're adding a brand new number to the equation. Remember, whatever you do to one side of an equation, you got to do the other. So we're going to add a 16 to both sides. That creates a perfect square. Darn it, I should have made this positive 17 because this is not going to work. Okay, well, we'll just follow this one through and we'll do the next one that'll work nicely. Okay? Now what you do is you simplify the right side. So it's negative 17 plus 16. And I'm going to have to bring that down really far because I'm running out of room. So negative 17 plus 16 is negative 1. And I'm going to show you what happens in this case. Okay, so I'm going to bring this way down so that my steps are right next to it. So we kind of did all of these steps were in this arrow. I need to make the arrow longer. Don't worry, I'm going to do more with you. Okay, so we had x plus 4. This is what we ended up with. X plus 4 squared equals negative 1. So if you look back up here, what we did was we took x squared plus 8x plus 16. We made it a perfect square, so it was a quick, easy factor. If we factored x squared plus 8x plus 16, we'd get x plus 4 times x plus 4. Remember, that's what we were talking about up here. That's why I showed you that. We forced this polynomial to become a perfect square, so it's easier to do. It's another way of solving. So now this is kind of new for some of you. To undo a square, the opposite operation is square root. So I want to get x by itself, so I'm going to square root both sides. So this is kind of not the step, this is just telling you something. Square root both sides. Okay, now again, this is where new things are going to hit you. So that's fine. So then that undoes my left side, so I have x plus 4. When you square root something, you're going to get a plus and a minus square root. So this will be plus or minus square root of negative 1. Now at this point, this is why I didn't like this problem, but we might as well just continue it. You guys don't know what it means to square root of negative 1. Right now, if you get out a calculator and you try to square root any kind of negative, you're going to get an error. This has no real solutions. So we're not going to continue it because square rooting a negative is no real solutions. Keep in mind what that means in your head. It still means we have a parabola. Our parabola looks like this though. It never crosses the x-axis. So there's no real solutions. When you get to algebra 2, you could continue this problem and your answer would be complex, which means it has an imaginary answer. Okay, so I kind of went through a lot of steps there, and we're going to do another one without me writing all the steps down. That may have helped some of you, it may not have helped others. Okay, so I'm going to do 3 more examples and see if that helps, and then we are going to do more in class as well. So let's do another example. So another example, and this one will come out all the way to the end, and I'll work it all the way out with you. Okay, so x squared minus 14x plus 3. This is not a perfect square. 3 is not a perfect square. This is not going to work. So we have to force this polynomial to become a perfect square polynomial. The first thing we have to do is get that 3 out of the way because it's not useful to us. Oops, this was supposed to equal negative 10. I almost messed another one up. Fix it. Okay, so we're going to subtract that 3 out of the way. Notice these don't matter if they're equal to 0 because they're not going to be anyway. We're going to be moving things around. So then what we have is x squared minus 14x equals negative 13. Okay? All right. The next step I like to do is I like to work these 2 steps at the same time. Okay? Because we're going to create a perfect square, I'm going to make the space for a perfect square. The first thing I know is just x goes here. The next step is to half b. So we're going to divide negative 14 by 2. That gives us negative 7. Oh, we forgot to put the boxes. Let's put our boxes in there. Now what goes in the boxes is we're going to square after we half b, we're going to square it. And so I say things like this: half b, square it, put it in the boxes. So half b, square it, and that's what goes into our boxes. Okay, so half of b was negative 7. We wrote that down. Now square negative 7. Now be careful. Negative 7 times negative 7 is positive 49. Every time you put something in the box, it's going to be positive because you're squaring a number. Okay, so then this gives us 36 down here. We're going to simplify the right-hand side, and now we have 36. Okay, so now we're set up to square root both sides. That was the whole point. We created a perfect square polynomial that we have factor for already because we don't need to go through that. And now we can solve this equation a little bit easier. The first step is to square root both sides. That undoes the square, that releases our x minus 7 from the square. But whatever we do to one side, we have to do the other. And when you square root something, it creates a plus and a minus answer. And we've kind of talked about that reason before. But the reason is that 36 could have 2 answers. It could be 6 times 6 or negative 6 times 6. So that's why there's 2 answers here. Both of these will give us 36. Okay, so then we have x minus 7 equals, now 36 is a square root. So we could do that. That's going to be plus or minus 6 because the square root of 36 is 6. If you don't know where to find that on your calculator, you would do second and find that x squared button in the first column. Okay, Now we're not done. Last time we were done because there's no real solutions, but this one does. So this gets a little confusing, so pay attention. I'm going to add 7 to both sides. But I want you to split this up. Really what we have going on here is we have positive 6 plus 7. And then we have, let's make it like, and then we have a negative 6 plus 7. So I split that 6 up. So our two answers are going to be 13 and 1. This parabola crosses the x-axis at 13 and 1. It has two real solutions. Okay, let's step through two more. If you think you got it, try one. Try this one, like once I write it down, try it, pause the video, and then see if you can get the right answer. If so, then you don't probably need to watch the rest of the video. You could do some of the homework. If you're not getting it right, see if you can find your mistake. Again, if you can find your mistake, you're making those really strong connections, and you're going to understand it better. First thing, 12 is not a perfect square. So that's in the way. So let's get it out of the way. We're going to move it over here to the other side just to get it out of the way. So now we have x squared minus 4x, and over here we have a 12. We want to put a box on each side to remind ourselves that we have to add something to both sides so we don't forget. I'm going to do two steps at once. So x squared, we're just going to write down as x, and then remember we half b. Well, half of negative 4 is negative 2, so that's what goes down here. Well, what goes in the boxes? This tells us what goes in the boxes. We have to square that negative 2. Well, negative 2 times negative 2 is positive 4. Now we have the perfect polynomial. That's how we got that step. But whatever we do to one side, we got to do the other. And so that's why it's important that you add that 4 to both sides. We've already factored it, but we got to make sure we add it to both sides. So this gives us 16 down here. I'm going to rewrite this so we can work with it. X minus 2 squared equals 16. Now we're going to solve it. Square root both sides, bringing in a plus and a minus in the process. Okay? Remember, square rooting a square, all it does is it clears it up. You don't do any kind of special thing there. It just clears up the square because that is the opposite operation of squaring. 16 is also a perfect square, so that's going to be plus or minus 4. All right, now we add 2 to both sides. And you want to do this twice. X equals positive 2 plus 4, and x equals positive 2 minus 4. So our two answers are going to be 6, negative 2. Again, this parabola crosses the x-axis in two places, 6 and negative 2. Let's try one more. Again, if you got that one right, you could probably just move on to the homework. If not, watch one more time. And you may have to go back and watch that original one again to see where the steps are coming from. Okay, x squared plus 20x equals 200. First thing is 11 is not a perfect square, so let's get it out of the way. It's not useful to us. So it just needs to go to the other side and get out of the way for now. So what does that give you over here? That gives you 189. Okay, we're going to remind ourselves that we have to add something to each side, which is the key to completing the square. So we're going to put boxes there. I'm going to work two steps at once. X squared just comes down here, becomes an x. Then I'm going to half 20. Well, half of 20 is 10, and it's positive, so that goes positive 10. Now we know what goes in the boxes. We square that. So 100 goes in the boxes, because 10 squared is 100. So now over here we have 289. All right, how do we get that x plus 10 out from under the square? We square root, because that's the opposite sign. But whatever we do to one side, got to do the other, and it results in a plus and a minus. So what we have now is x plus 10 equals, and 289 comes out nice too, plus or minus 17. Sometimes it's going to be decimals. We'll do some decimals in class too. We're almost done. Subtract 10 from both sides. Solve it twice. It's going to be negative 10 plus 17, and x is going to be negative 10 minus 17. So what are my two answers? 7 and negative 27. Did I do that right? Yes. So you could write it like this, negative 27 and 7. This is a pretty wide parabola. It's a pretty big parabola because it's going to cross at negative 27 and 7. So if you were to try to put this in your calculator, you wouldn't even see both solutions. Okay, so that's completing the square. It's going to take a lot of practice. We're going to do some in class, but you really need to take your time and do your homework on this. Please don't turn in homework that you're not showing work. You can't complete the square without trying to show work. So if you turn it in, I'm going to give you a 1 out of 10 and tell you to redo it because you really didn't do any work if you didn't show it.